everyone. My name is Mihai Budiu. I am with the VMware Research, and I am currently a co-chair of the P4 Language Design Working Group. And I am very pleased to introduce Jeff Alpern, who is a Director of Product Management at OpenFlow. He will talk about a journey from OpenFlow to P4.
Oh, thank you, Mihai. Yeah, so what we wanted to do in this presentation is a testimonial, from a viewpoint of actually having done this out there. What were the experiences? And we had one that we knew from the very beginning, and we had one that kind of shocked us on that. So let me just for a second talk about NovaFlow in the terms of this context. We've been out in the match action pipeline world for a little over 7 years. We think we're the leader in that. We have tier one service providers all over the world that use our product. We have a giant out of Silicon Valley that uses the product, uses specifically the OpenFlow version of it, which we're in very, very early on. And then as Tofino came out, we got extremely excited about that. And we moved to Tofino, and now, in the last year, to P4 speaker, native on that. And I'll talk a little bit about that transition, because it's one of the things that makes us more knowledgeable than anybody else out there, I think. Now on top of this, kind of my area is to look at the market and find segments where we think our technology is really impactful. The match action pipelines are really impactful and aren't being addressed. And one of those that we identified early on and we're having tremendous success on is in the CyberMapper product line, and that is sitting in front of security tool farms, load balancing, doing all the work of that at very, very high volumes, and doing sophisticated stuff in the match action pipelines. So we are a big consumer of the NOS and runtimes, out there in OpenFlow and in P4 on this. So I talked a little bit about this transition. An interesting story here is it wasn't direct. We had so many big tier one consumers on, providers on it that weren't ready to move to P4. But they wanted to have that terabit speed on Tofino. So we actually, as an interim product, as a transition product, we created a complete OpenFlow environment sitting on top of P4, sitting on top of Tofino. A very, very hard thing to do, but we did it, and we transitioned all of our guys over. We're now in a total P4 native environment out there. So to get right to what the claim was in the abstract for this is we've seen two areas where we believe there's an order of magnitude improvement. The first one is pretty obvious. All you have to do is look at the data sheet specs, and you see that in the hardware side, we're going to get that. I'll go into that a little bit. The second one is in development. Now, in all of these, we want to make sure that whenever I'm talking about it, that you understand that we are absolutely dedicated to full match action pipeline implementations, not partials, not some. We had the most complete 1.5 OpenFlow out there. I'll talk about extensions, clearly, a complete set of stuff out there. So whenever I talk about performance and constraints and move, I'm talking about moving from OpenFlow 1.5 to P4 runtime at the tip of the spear right now. So we want to introduce the two areas, where we've seen just tremendous improvement. And again, I'm coming as the application, as the application developer out there. So the first one, of course, is just the hardware. All I have to do is read the hardware specs, and you see this roll in. Again, we're going after match action pipelines. We're going after the opportunities that require the most sophisticated pipelines out there. Can't be done in standard Broadcom chips, that want the flexibility of, innovating and developing their own structures. So until Tofino came along, the only way to really implement that was over on the network processing chips. So we had that for a number of years. We got all these big customers at very, very powerful solutions out there. But the issue was network processors have limits. And so we were at about the 400 gig throughput arena. When Barefoot came along, and with a Tofino chip, you're seeing 100 gig levels move to terabit levels. And we were able to achieve that. We have customers out there using OpenFlow at terabit levels on Barefoot. So this was just the straight magic of the chip coming through and the power of P4. But mostly on the first wave, we were running OpenFlow on top of Tofino and bringing the big carriers over into this world. What I'm going to talk about next is when we moved and started to write the application code native P4, what things did we run into that also impacted this throughput and gave us a surprising result out there. So the second order of magnitude is in development. And it was really hard. It was hard to see this coming when to be just straightforward out there. We expected that P4 would be more flexible, but about the same development cost, about the same development pace as OpenFlow, and to find that there were certain areas where we got huge productivity gains, cut the development time by an order of magnitude was surprising. And that's one of the reasons I wanted to do this speech was to share that and make sure that everybody sees where those are. So this was a big surprise, and it's based around a very straightforward thing that is not talked about. Barefoot undermarketed it, but in OpenFlow, the header is baked into the spec. What fields you can search on, what fields you can match on, all of that's in the spec out there. When you go to P4 doesn't talk anything about the headers, doesn't talk anything about what you can match on. It talks about how you get that. And it provides you a parser, a very high level parser. And that has huge, huge ramifications. And I'll show you that. What I want to do is I want to do it around a real world example, not in the labs, not in the toy product, but a huge opportunity that came our way where we had to respond to a very complex environment. And I'll spend a little bit of time just walking you through that environment so you understand that it wasn't, that we're not just making this claim because we wrote a couple hundred lines of code. But what came about was an opportunity for one of the big providers in one of the spaces to move to SRv6 in our CyberMapper product. And I'll show you what that means. Most important thing is we had limited knowledge about SRv6 and nothing in our product, nothing about how to deal with that header. So we were starting at day one and we had great results. So let's talk quickly about our environment, just over it. So the main thing is we're a bump in the wire. This would be your gateway router. This is the first router in your central office out there. We provide a set of switching capabilities, Tofino switching capabilities that intercepts traffic, load balances it to a tool farm. Think of DDoS or firewall out there, and brings it back and sends it on. Okay, pretty straightforward. Claim to fame, what makes us powerful in the marketplace is that we're doing this at silicon speed on Tofino, and we're hugely, much cheaper, much more economical than F5 A10, which is doing it off in more proprietary stuff. That Barefoot, Tofino chip is just tremendous. What we got asked to do was now make this device and therefore that security cluster addressable from anywhere in the market, anywhere in the network for a service provider. So if you're a service provider and you have $1 million worth of Fortinet firewall gear sitting in Chicago and it's not busy, but your Atlanta office is slammed, they want to be able to route packets from wherever across their net to this proxy and get them serviced out there for firewall. And the way that they want to do it is through an SRv6 header out there that will both get them to this device, and then through the SID inside the SRv6 header, tell them what services they want. So, our task was to add this functionality onto the product we already had. So a little bit busy, and I'm not going to take you through all of it, but you can look at the slides when you make it available. This wasn't a trivial new header. This was a sophisticated new header that at every hop we had to manipulate. So a really tough new task out there. And in this task, we're trying to get a packet from server A here to server B, but the security policy says, all right, for it to get over there, it's got to go through this tool chain, this security sequence. And how do you do that? How do you set up a header to do that? And at each level in that SRv6 header, what do you have to change? What do you have to pop? What do you have to push? How do we get it out? How do we get it back? Not the details for the presentation, other than to say, again, this is a big requirement out there. And our experience with it was just sensational. So the task, accept the header, match on it to make sure that the security service can be done here, load balance it to the farm. When it comes back, updates the service router header so that it heads off to the next task, whether it's going to another firewall here or another service here, or headed back to where it came from. So what do we have to do that? And this is our P4 technology stack. And our claim to fame here is that we own every piece in the stack. If you start down here with the Tofino chip, we develop the NOS for that, P4 NOS, that will take the controller request to install this pipeline, to add services, to do all of that stuff, and install it on Tofino. We have a P4 runtime speaker that meets all the P4 speaker specs, plus a whole bunch of O&M stuff that we've had in our product forever and ever, that will compile a pipeline, push it into the switch. And then when my group develops the applications that make requests into the P4 speaker, use this to drive all of that. So when I'm talking about what we're seeing is, as an application developer here, how do all these tools help me and move me forward quicker in P4 than they did in OpenFlow. But when you come to NovaFlow, we have everything in the stack. So here's the payoff. This is the money slide. In OpenFlow, because the match fields you could match on were in the spec, that meant that the header was in the spec. And if you had a client that had a new requirement, for example, they wanted to do L2 MPLS out there, it wasn't in the spec. So the spec had this idea of extensions that you could do, experimenters. And we ended up, over time, writing all of these. These were experimenters that we created and made commercial and brought things into the market, including this one, VXLAN encapsulation. So if you go back to the very first time Barefoot brought Tofino to the marketplace, they had a technology day, McEwen stands up and says, what this product does is let the application developer bring out in weeks what it took Broadcom 3+ years to do. And he used VXLAN as that example. I'm using today his same claim, only now I'm talking about SRv6. And this is a code snippet from the P4 code that we wrote to parse that SRv6 packet and deparse it when it went out, manipulate it, and put this stuff on the bus. This is less than 200 lines of code to introduce the new header. We wrote it in a couple of days. We got the first working code out to our client in a proof of concept in a couple of weeks. And it was just sensational, because these things, having lived through them and having written them over in microcode on the network processor, were months. They were just flat staff months to implement them. This was a couple of staff weeks to get a working copy, probably 3 staff months to get a commercial copy out there. So when we talk about an order of magnitude, we're really saying anything you touch where you need new headers, where you need headers not handled in the spec on OpenFlow, you're going to experience this tremendous uplift. We've done the same thing over using INT, in network telemetry out there, put those headers in, got the same, rapid development and response on that. So this is the most discernible, biggest win as you move from OpenFlow to P4. Now there's other things, and I didn't go through these in detail, but I'll share them with you. So we talked about big win in the parser. Whenever you have new headers, or whenever you have headers where you are only dealing with some of them, but not all the exceptions and all that, you need to go and expand your capabilities to handle that header. You're going to experience this huge win, in OpenFlow to P4. Another one that is related is that when that P4 compiler or the P4 parser parses the packet, it puts all the data on the metabus. We on OpenFlow always had problems moving from table to table, keeping the state that, the kind of internal state that we had done in one table, so that some table down the pipeline could grab that. Not a problem in P4, not on Tofino. That's taken care of. Many things are what we thought, so like writing the load balancer, it's about the same. There's hard to say whether P4 or OpenFlow, or which one's faster, what code's tighter, what code's easy to read. They're just equals on that. And then when it came back, we actually, as we sent the packet off to the tool farm, when we put the SRv6 packet in, we also put another, we also stuffed some metadata in the packet in another area. And when it came back from the tool farm, we harvested that so we could get a state even after the packet had left the Tofino, between when it left and when it came back, able to do that, in a couple of days. So this updating and routing was another big win out there. So to summarize, we've had tremendous experience with P4. We think that McEwen and Stanford got a good jump on it in the second round, and made the match action pipeline world better. And we wanted to share our experiences and how productivity went up, and certainly how throughput went up. Also, just make sure that everybody knows that we make the NOS and the P4 runtime speaker available to anybody that would like to create apps like we have with it. So with that, I will turn it back over.